Now finally, I'll show you what you just programmed. So open up the log file viewer and look for the text files. So we'll start by loading the scan. So we had a look at the scan before, and you can travel using the slider through all scan measurements. But now let's load the cylinders as well. So the last program you've written produces this cylinders.txt, and if you load this, you will now see these small green disks which depict your detected cylinders in the robot's coordinate system. So now let's have a look at this. So we detect all 6 cylinders in the beginning. Then as we move along, one of the cylinders moves into the shadow of the other cylinder, and correctly we omit this cylinder while still detecting the cylinder in the foreground. Now we can move through our entire scan. Sometimes we don't see cylinders. For example, we are unable to detect this cylinder here, probably due to our threshold. Let's load the reference trajectory in addition. So now you can compare the position of the robot and its scan data. Now let's load the absolute positions of the cylinders in the arena as well. So this is this file. And now you can see, as the robot was here, there were 2 landmarks to his right and 4 landmarks to his left, and it stood right between 2 of those landmarks. And as it moves through the trajectory, you can see how the situation that you see from above fits the measurement data of the robot. There's one more cool thing. Now remember the positions that you produced in the beginning using the MotorTix. If you open that as well, then what the log file viewer will do is it will use your Cartesian coordinates that you produced in the scanner's coordinate system, and it will use the filtered position that you produced in order to project the detected cylinders into real-world coordinates. So as you move along, you see sometimes they fit quite well to the reference coordinates, and sometimes they're pretty much off, especially when the robot turns. And now it will be our next task to use the differences between the measured coordinates and the known locations of the cylinders in the world to correct the trajectory of the robot. So congratulations, you just programmed code that takes the MotorTix of the robot and transforms them into a real-world trajectory, and you also managed to determine the locations of the cylinders in the scanner's coordinate system. And putting that together, you can see how well the location of the cylinders fits the known positions in the world.